So when we're looking at compound measure, it is all about looking at the units that you're dealing with, and that enables you to work out what you've got to do with your quantities, whether you have to divide or multiply, or which one you divide by which. So let's have a look at what we mean by that. So density has units of grams per centimetre cubed, or it might be kilograms per metre cubed, or something that looks like that. And what does that mean? Well, each of these represents, so this is grams divided by centimetres cubed, this is kilograms divided by meters cubed. Okay, and we know what both of these units are. So that's a mass on the top, and that's a volume there. So density is mass divided by volume, and over here we have a mass divided by volume. So let's apply this to a question. So we have polystyrene, a piece of polystyrene which has a mass of 500 grams and a volume of, so even if we hadn't got to the point where we had mass over volume, as in we'd written that formula, then we can see that here we've got, we know it's going to be in grams per centimetre cubed. Here we've got grams, so we've got grams, we've got centimetres cubed. So therefore, to get to the units we want in the answer, it's just like matching the units. We're going to do 500 grams divided by 1,250 centimetres cubed. 500, 1,250 gives us 0.4 grams per centimetre cubed. And another example, or applying this, so therefore calculate the mass of polystyrene with volume 0.34 meters cubed. So we have a volume of 0.34 meters cubed. First of all, we're going to want to convert that into centimeters cubed. So meters to centimeters, 1 to 100 squared. So meters squared to centimeters squared, 1 to 10,000. So meters cubed to centimeters cubed is 1 to 1 million. Okay, so therefore, how do we get from meters cubed to centimeters cubed? We multiply by a million. Multiply this by a million, we're going to get 34,000, because the decimal place is going to move six places. So we've got that many centimeters cubed, and we know we have a density equal to 0.4 grams per centimetre cubed. So we've got, and we want to get to a mass. So we want to get to an answer in grams. That's what our answer wants to look like. So what do we do with these two units? Well, if we do centimetres cubed multiplied by grams divided by centimetres cubed, which is our density, then our centimetres cubed cancel out, and we'll just be left with grams, which is what we want. So again, we're looking at those units. So we're going to multiply our volume by our density to get our mass, which again you could also get from looking at from rearranging this. So mass is density multiplied by volume. So we're going to multiply these two together, which gives us 136,000 grams, which is 136 kilograms. We can apply a similar logic when we're looking at pressure. So pressure has units, newtons per meter squared, newton over meter squared. So that's a force and that's an area. So a force of 108 newtons is applied across 4.5 meters squared. Work out the pressure. So we've got 108 newtons and we've got 4.5 meters squared, and we want to end up in a unit of newton per meter squared. So how do we get that unit? Well, we're going to have to take these newtons here and divide by these meters squared there. So pressure is the force we've got, which is that, divided by the area, which is that. 108 divided by 4.5, sounds like it might go into a nice whole number. 24 newtons per meter squared. So what force would be needed to cause the same pressure, i.e. the one we just looked at, 24 newtons per meter squared, on an area of 2,500 centimeters squared? First things first, let's convert. So 1 meter is 100 centimeters, sorry. So 1 meter squared is 100 squared is 10,000 centimeters squared. How do we get from centimeters squared to meter squared? We divide by 10,000. That centimeter squared is 0.25 meters squared, because we divided by 10,000. So now we've got 0.25 meters squared. We want to end up with a force, so we want to end up with newtons. We've got 24 newtons per meter squared, or newtons over meter squared. Let's write that as newtons divided by meter squared, and we've got 0.25 meters squared. And again, we can see if we multiply these together, the meter squared will cancel out and we'll just be left with newtons. So the force equals 24 multiplied by 0.25, which is going to give us 6, because it's a quarter, isn't it? So the answer is 6 newtons. So it's all about matching up those units. Okay, first of all, we needed this to be a meter squared because we've got our pressure in newtons per meter squared. And then we've got an area in meters squared, and we've got a pressure in newtons per meter squared. So it's all about, okay, well, we want to end up as a force, which is newtons. So how do we cancel those out? If we multiply those together, when we multiplied newtons per meter squared by meter squared, you can see these meters squared cancel out. So we just get 24 times 0.25 newtons, which is 6 newtons.